Hi, we're going to talk about how to write quadratic functions. Now this video does not address the definition of quadratics, so it's just based on the points on the graph. So I have a standard form and the vertex form, which you need to know. In vertex form, you're going to need to know that in this form hk are going to be the coordinates of the vertex. If you want to write an equation of a quadratic function in any form, you need to know either the vertex and another point or 3 points on the graph. So let's begin with an easier case, which is when you know the vertex and another point. We're going to start by filling in the equation for we're going to take the vertex form and we're going to substitute the coordinates of the vertex, which will give us this equation. And this equation has three unknowns, y, x, and a. But when we're going to use another point that's given to us, then you will be able to eliminate everything except a. So it's going to be 1 equals a times 3 minus 2 squared minus 1. And in this case we're going to get, we're going to need to solve it for a. I think we can see that 2 equals a. So a is going to be 2. And after that you can go ahead and substitute that. So f of x is going to be 2 times x minus h squared plus, plus k. We know h and k, I'm sorry, I already had them earlier. 2 times x minus 2 squared minus 1. And since we need standard form, all we need to do is expand this. So f of x is going to equal 2 times x squared minus 4x plus 4. And then minus 1, which is going to give us 2x squared minus 8x plus 8 minus 1. And our final answer in standard form will be f of x equals 2x squared minus 8x plus 7. Let's take a look at another one. Again, we have the vertex and another point. We're going to repeat the same process. So the first thing we'll do is we substitute the coordinates of the vertex, which is 1, 6, so y equals a times x minus 1 squared plus 6. And after that we are going to use the point that is given to us, another point. Negative 3 equals a times negative 2 minus 1 squared plus 6. It's a little bit more involved than the previous problem. So we're going to move this on that side. We're going to have negative 9 equals, this is negative 3 squared, which is going to give us 3. So 3a, which means a is going to equal negative 3. Now we know that. We can take this equation here and write f of x equals negative 3 times x minus 1 squared plus 6, and then we just go ahead and expand all this. It's going to be negative 3 times x squared minus 2x plus 1 plus 6, which is negative 3x squared plus 6x minus 3 plus 6, and our final equation is going to be negative 3x squared plus 6x plus 3. Again, we're trying to write in the standard form. If you needed that in the vertex form, your answer is right here. Okay, there's one more, the vertex and another point. Let's go ahead and do this one. Same thing. So we're going to write y equals a times x minus 0, x plus 5, right? X plus 5. Let me fix this. My bad, I looked at the wrong number. Well, it's 5. I don't know, it's not working. X plus 5 squared, and then we're going to have plus 0 or minus 0, whichever way you want it. It's irrelevant. So we can discard that. And then we're going to use the point here. So we're going to do 2 equals a negative 3 plus 5 squared. That is going to give us 2. 2 squared is 4, so 2 equals 4a. and then a is going to equal 1/2. And then we're going to go ahead and substitute that. So we're going to have our equation now in the following form. F of x equals 1/2 times x plus 5 squared. We don't need to write plus anything else because that's all we need here. So it's going to be 1/2 times x squared plus 10x plus 25. And the final equation here is going to be 1/2 times x squared plus 5x plus 25 halves. Now we're going to take a look at a situation when 3 points are given. This will require you to solve a system of 3 equations, but it's going to be a little bit easier. Basically, your approach is going to be, since all you have is 3 points, is the easiest thing to do is take the standard form and just plug each of these 2 points, all 3 points, and that's going to end up giving you 3 equations. So we're going to use the standard form here. So our equation then is going to be, when we substitute, and what I'm going to do, I'm going to use this form, ax squared plus bx plus c equals y. So I'm just reversing that. So with the first equation, it's going to be negative, a is 3, x is 3, so it's 3 squared, which is 9a, right? You multiply, you square the 3 times a, plus 3b, plug in 3 for x, plus c equals negative 1. Your second equation is going to be obtained with the second point, so you plug in 4 for x. That's going to be 16a plus 4b plus c equals 2. And finally, you're going to plug in this last point, so x is negative 1. It's going to give us a minus b plus c equals 7. Okay? Again, what we're trying to do here is we're taking each one of these points, not what we're trying, what we're doing. We're taking each one of these points and we're substituting the x and the y coordinates into this equation, and that's going to give us these 3 equations. So it is a system with 3 variables and 3 equations, but the nice thing about this system is that over here they're all going to have just c, and you can easily eliminate c by combining equations. So what I can do as one of the possibilities is, if I subtract, well, I can pick any equations that I want. So if I take the, let me number them, this is typically how I show problems like this. If I do the first equation minus the second equation, that's going to give me 9a minus 16a, which is going to be negative 7a. 3b minus 4b will give you minus b. C minus c is going to cancel. And negative 1 minus 2 will give you negative 3. And then what I'll do, also I'm going to take, let's say, I can do the first equation minus the third equation. So the 9a minus a will give you 8a. 3b minus negative b will give you plus 4b. C's cancel, and negative 1 minus 7 will give you negative 8. And what we need to do now is solve this system of 2 equations with 2 variables. So if we multiply the first equation by 4, this will allow us to eliminate b. I'm not going to spend too much time explaining that. You would need to watch another video to understand how to solve systems like this. That's not what I'm trying to accomplish here. So it's going to be negative 28a minus 4b equals negative 12. This is 8a plus 4b equals negative 8. We add them together to eliminate b. This is going to give us negative 20a equals negative 20, which means a is 1. And then from here we can find the rest. So you take this value, plug it into, for example, this equation, negative 7a minus b equals negative 3. So a is 1. That means negative 7 minus b equals negative 3. which means negative b is going to be 4, which means b is negative 4. And then you can finally plug in both of them in, and you can see that c is going to be 2. And our equation is going to be f of x equals x squared minus 4b, minus 4x plus 2. Okay. If you're getting really confused here, I suggest watching videos on solving systems of 3 equations with 3 variables, because that's one thing that you must know how to do. Okay, our next equation, so we're going to do exactly the same thing. We got 3 points given to us, we will substitute them. So the first one is going to be 4a plus 2b plus c equals negative 1. That's 2, negative 1. The second equation is going to give us, when we substitute this is going to be 16a plus 4b plus c equals negative 17. And the last point, when we substitute that, we plug it in negative 1 for x, so it's going to be a minus b plus c equals negative 7. You can do the same thing. You can take, if I number them again, you can do the first minus the second. So here that's going to give us 4, we're just trying to eliminate c since c has a coefficient of 1 in each one. So it's going to be negative 12a, 2b minus 4b will give you minus 2b, c cancels, 1 minus negative 17 will give you 16, and then you can do 1 minus 3. It doesn't really matter which how you pair them, it's going to work the same way. So that's 4a minus a will give you 3a, 2b minus negative b is going to be plus 3b, and 1 minus negative 7 will give you 6. So now we have negative 12a minus 2b equals 16, and we have 3a plus 3b equals 6. I want to show you a little shortcut here. If I divide the first equation by 2 and now I divide the second equation by 3, what I'm going to get is going to be negative 6a minus b equals 8, a plus b equals 2. And what I need to do now is, if I add them together, this will easily eliminate b, and that's going to give us, what are we getting here? Negative 5a equals 10, which means a equals negative 2. By substituting everything else, I'm not going to do this here. You can figure out that b is going to equal 4 and c is going to equal negative 1. And your final equation is going to be f of x equals negative 2x squared plus 4x minus 1. We got one more example, same type of question. So we are going to do exactly the same thing. These are the points. Plug in the first point. We're going to get 4a plus 2b plus c equals negative 4. The second point is going to be 4a minus 2b plus c equals 12. And the third point is going to give us 64a plus 8b plus c equals 2. Again, it's your choice, but if you, with this problem, it's going to work a little bit easier, because if you look at the first two equations, you can find one unknown right away. If you subtract the first equation minus the second equation, you will actually cancel a and b. I'm sorry, a and c. So 4a minus 4a gives you 0. 2b minus negative 2b will give you 4b. C cancels. Negative 4 minus 12 is negative 16, which means b equals negative 4. Okay? So what we can do is we can take any two equations together, except you can't use the first two because you already used them, and substitute b equals negative 4. So for example, I do the first one, so I'm going to get 4a minus 8 plus c equals negative 4. And I'm going to take the last equation, so 64a minus 32 plus c equals 2. And I can work with that now. I can subtract them to eliminate c. So 4 minus 64 gives you negative 60a. Negative 8 minus negative 32 will give you plus 24. C cancels, and we are going to get negative 4 minus 2 is negative 6. So negative 60a equals negative 30, and a equals 1/2. And you can also substitute b and a into any one of these equations, and you're going to get that c equals 2. And your equation is going to be f of x equals, what do we have here? 1/2 x squared minus 4x plus 2. Okay, so this is how it's done. I hope this helps.